Good day, students. We are moving on to composite mapping. Now, composite mapping is when we having two or more mappings coming together. So that is composite mapping. For example, look at this. We are having two mappings here, mappings of F and mapping of G. So you realize that if insert a mapping of F takes an element in X and produces an image in Z, then the mapping of G takes an element in Z and produces an image in Y. Then the composite, the mappings of FOG, that is, you are having what the taking an element in X produces an image in Y. So that when you combine two or more sets to more mappings together, that is what we refer to as composite mapping. So from this mapping, you realize that what if you are picking an element G here, P here, so it produces A in this Z, set Z. This Z now becomes the domain here, then now produces X in Y. So that means the composite of GOF will be what? X. For the composite mapping of P, here is what? X. The composite mapping of Q is what will be X also. So Q produces C in Z and now produces X in. Then that of R will produce D in Z and now produces Y in Y. Then that of Z produces B in Z, now produces Z in Y. So when you combine two or more mappings together, it's called composite mapping. So when you are referring to identifying composite mapping, so that means this GOF can be used. That means you are combining mappings of G and mappings of F together. Now, let's look at this example. If the mapping of F and that of G be mappings on the set of real number defined by, so the relationship between X is what? X plus 1 and that of G is X plus 1 square. Then you are now totally for GOF. So this GOF is the composite mapping. To do this, so GOF can still be written as GF of X. So we want to combine these two mapping G and F. The mapping of F is X plus 1. The mapping of G of X is for X plus 1 square. So you are now trying to come. That means you are trying to get a formula that connects these two mappings together. But anytime you are dealing with composite mapping, to get the composite of this, you start from the back. So this GOF can be written as GF of X. So first thing, you have to remove this F. So that means you are going to substitute the mapping of F of X here. So F of X is for X plus 1. So you know here you are having F of X is what? X plus 1 plus 1. You are having X plus 1 there. So because of that, you have to remove this F, you now substitute X plus 1 to remove F of X here. So you now have G of X plus 1, G of X plus 1. So you've been able to remove this F. So you are trying to get a composite mapping for the combination of the two mapping. So now from here you can say that let A be equal to X plus 1. If you say you are letting A pick an alphabet is equal to X plus 1. So in place of X plus 1, I'm going to put G of A. Now, you know our G of X here, our G of X is x plus 1 square. So this is what I'm going to do now. In place of this ax, I'm going to represent what? Put g, since I'm having g of a here. So in place of this x, I'm now putting a into this formula. So in place of x, I'll now put a plus 1 square. A plus 1 square. And you will remember that we have represented our a to be x plus 1. We've represented our a to be x plus 1. So in place of this a, I'm going to substitute x plus 1 back. When you substitute, that means in place of this a plus 1 square, in place of this a, I put x plus 1, then plus this one. Everything is now square. So let me simplify what is inside the bracket. So open the bracket first. I'm having x plus 1 plus this one. So you now have x plus 1 plus 1. 1 plus 1 will give us what? Plus 2. X plus 2 square. So from here, I will now expand. So x plus 1 times x plus 1. So x plus 2 times x plus 2. So you open the bracket. X times x plus 2 plus 2 times x plus 2. So you expand. X times x will give us x squared. X times 2 will give us plus 2x. 2 times x will give us 2x. 2 times 2 will give us plus 4. So when you simplify, x squared plus 4x plus 4. So when you find the composites of GOF, it's going to give you x squared plus 4x plus 4. So that is when you combine the mapping of this and this together, you are going to get x squared plus 4x plus 4. So you must take note whenever you are dealing with the composite mapping. You start from the back here, from the back one, substitute. So to remove this f of x, so I substituted the value for x plus 1. So I was able to do that. So from there, I represented this one to a. X plus 1 is represented as a. So I want to remove this g now. To remove this g, I will now substitute the value for a into what g of x is representing. So that means in place of a, I'm putting what? In place of x, I'll put what? A plus 1. So from here, since you have represented a to be what? X plus 1. So you now substitute it back to be able to get your expression in terms of x. So now let's do another example. Let the mapping of f and g on the set of real numbers be defined by f of x is equal to 2x squared minus 3 and g of x be equal to x plus 1. Find g, f and fg. So first of all, let's look for gf. Gf is the same thing as what? Gf of x. So first of all, whenever you are dealing with composite mapping, you should always know that you have to start from the back. So to remove this f of x, our f of x here is what? Our f of x is 2x squared minus 3. So to remove this f of x, I'm going to substitute 2x squared minus 3 into that position. So that's you are now having g into bracket 2x squared minus 3. So I will now I can use a to represent 2x squared minus 3. So in place of 2x squared minus 3, I'm going to put what? A, since we are saying we are using a to represent it. So that means I'm having g of a. So to remove this g, so you know that our g of x is equal to x plus 1. From the question, g of x is equal to x plus 1. So since we know that it's equal to x plus 1, so that means in place of x here, I'm going to put a, since this is a here. So in place of x, wherever I see x, I put a plus 1. So that is what, to remove this g, I'm going to put this. So in place of x, I'm going, since I'm having, so as I've said, when you are having g of a, so now, and from the question, our g of x is equal to x plus 1. X plus 1. So what are you supposed to do now? You are going to remove this g, you are going to what? Substitute a for our g of x is x plus 1. Wherever you are seeing x, you put a. So that means you're having what? A plus 1. Now, since our a, we've represented our a to be 2x squared minus 3. So what you are going to do, you are going to substitute 2x squared minus 3 where you are having a. When you substitute that, the a is for 2x squared minus 3, then plus this one. So you are going to simplify this. So you are having 2x squared minus 3 plus 1 will give us minus 2. Minus 2. Now, so it means that our g of x, gf of x, this composite mapping is now 2x squared minus 2. Now, we also told to look for the second part, f of g. fg is same thing as saying fg of x. So anytime you are dealing with composite mapping, you always start from the one at the back. So now you are having your g of x at the back here. First of all, to remove this g, you are going to what? Substitute into the formula for g of x. And you know our g of x is what? X is equal to x plus 1. So to remove the g, so now I'm going to substitute x plus 1. So x plus 1. So since f of x plus 1, I'm going to now represent this x plus 1 with a. So when you represent it with a, so that means our x plus 1 is representing a. So we now substitute where you're having what? In place of x plus 1, I'm going to put what? F of a. And you know our f of x, our f of x is what? 2x squared minus 3. So since you are having a here, you are going to substitute, you will substitute a where you are having x. So that means you have your 2 in place of x, put what? A squared minus 3. 2a squared minus 3. Since we know that what our a is represented by our x plus 1, since our a is equal to x plus 1, so in place of a, I'm going to put what? X plus 1 back. We want to get the expression in terms of x. So when you expand x plus 1, you have 2 into bracket x plus 1 squared minus 3. So first of all, expand x plus 1. When you expand x plus 1 to give x squared plus 2x plus 1, then minus 3. So you use these two to multiply everything inside the bracket. You having 2 times x squared is 2x squared. 2 times 2x is 4x. 2 times 1 is 2, then minus 3. So you can simplify. You are now having 2x squared plus 4x. 2 minus 3 is what? Minus 1. So that means the composite mapping for g of x is now 2x squared minus 4x minus 1. For the work practice, number 1, the function f and g are defined by f of x is 4x minus 1 and g of x is 2x plus 3 respectively. Determine the composite function of g of x, gf of x, and fg of x. Number 2, the mappings of f and g on the set of real numbers are defined by f of x is equal to 2x plus 3 and g of x is equal to 3x minus 2. Write expression for the composite mapping of f, g of x. So this same thing, also same thing as f g of x. It says same thing. So what is here is also the same thing as g f of x. So they mean the same. Or you can also call GOF, FOG. It's still the same thing you are talking about. Number 3, the mappings F and G are defined by the diagram below. So this happens to be the diagram we are talking about. So mappings F and G. So this set, this is the domain, codomain, but this is another codomain. So you are now told to determine this. A, when f is minus 3 plus when x is 4. B, when x is what? 2, and when x is plus f of 4. G, when it's 9 plus g minus 5. D, g f plus g minus 5. Then you having E, is this one give us a composite mapping. So gf of minus 3. So same thing as saying we having gf minus 3. This one same thing as saying gf4. So still same thing. So, and this remaining ones also. Please ensure you like, subscribe and comment on this video. Thank you.